So moving ahead, so we are going to solve the seventh question of ODE 2020. So again, this question comes from Laplace transform. Using Laplace transform, the initial value problem, t y does something equation, we are given this condition, initial conditions, where y does 0 is arbitrary. Does this problem have a unique solution? Like, I think there should be some clarity, like what is t. Like when I was first solving this question, I got confused that what is t here. Is it a constant or something else? But while solving, I realized that y is nothing but a function of t. Y is a function of t. So there should be some clarity. There should be some more information here which can pave the way for more clarity to the students. So I thought so. Also, like many times, like we have to assume, some of you might have solved the question of 2021, where wherein was a question that we have to prove something, but the answer was coming out to be 0, and the actual answer was 0, but it was, I think, printing error in the paper which told that we need to prove something with some equation to something expression. So many students got panicked during the exam time, like the answers they are getting is not matching with what is given in the paper. So sometimes we need to be considerate and need to be calm down. Sometimes we need to be need to have our assumption that something may happen, uh, to to be calm during the exam time. So these type of questions are lesson for those situations. So solving this, uh, given we know that, sorry, we know that y is function of t. So given expression, is nothing but t y double dash 2ty 2y t, taking Laplace transform both sides. So it will become something like this: Laplace transform of t y dash whatever dash 2 Laplace transform of t y dash 2 Laplace transform of y is Laplace transform of 2. So there is an identity that the Laplace transform of t f of t is minus of dp by d by dp का differentiation of f of p. F of p is where f of p is Laplace transform of f of t. So similarly we will be using this identity here. So it will become minus d by dp of Laplace transform of y double dash fine plus 2 times of, here it will come minus also, minus of d by dp of Laplace transform of y dash plus 2 times of Laplace transform of y, Laplace transform of 2 by 2, Laplace transform of 2 is 2 by pi. Similarly, using the same the identities of Laplace transform, we'll be writing this: p Laplace transform of y, p square minus p y of 0 y dash 0 minus 2 dy dp of nothing but what we'll be doing here, p Laplace transform of y minus y0. Fine, no? Yeah. 2 Laplace transform of y is 2 by p. For the sake of simplicity, let's assume that say Laplace transform of y is small l. Fine. And given here also it is given that y dash 0 is arbitrary, like, and y dash 0 is some c, where c is some constant. For the sake of simplicity only, to make our life easier while doing calculation, p square l minus p, 0 is y of 0 is 3, y of 0 is 1, y of 0 is c, minus 2 dp p l minus y of 0 is 1, plus twice of p, twice of l, 2 by p. So what we'll be doing here is just differentiating. Here will be p. So if we differentiate it, 2p l p square dl by dp, minus 1 0 minus 2 l p dl by dp 0 plus 2l 2 by 2p. Now we solve it, like what we do is that, like, taking the terms dl by dp ka term, segregating the terms, it will become p square, rather minus p square minus 2p. Fine. Then segregating the terms of l, minus 2p from here, this term will come minus 2, and this term will come, I think it will get cancelled. Yeah, plus 1 fine. So it would be 2p. What we do is that multiply with minus 1, so it will become something like that, dl by dp p square by 2p. Let's divide by 2p also. We have space constant, so we'll be solving in limited space too, and we need to be practiced with respect to exam too. So this get cancelled, so it becomes l by l 2p p square 2p. This become minus 1 plus 1 on the other side, so minus 2. Fine. And this now becomes ODE of format dy by dx plus y f of x g of x. This can be solved by integrating factor approach. The integrating factor is nothing but e raised to the power 2p p plus 2 dp. Basically it will get cancelled, this will get cancelled, p plus p by 2 p upon p 2 upon p plus 2. This will become 2 ln p, so it will become p plus 2 ka whole square. So multiplying it, so it will become l p plus 2 ka whole square. Also, like we have multiplied, it will come here also, p square plus 2p. Okay, what we can do now is that 1 upon 2 by p plus 2. If we multiply, if we put it here, it will get cancelled. It will be here. It will become something like 1 by 2p, 1 plus 2p, 2 by p, sorry. So it will become 1 minus 4 by p square. Yeah, I think we are yeah, 1 by p plus 2 का whole square. Now what we do is that I think we are correct. Yeah. So now L is nothing but Laplace transform of y. P plus 2 का whole square minus 4 by p square p plus 2 का whole square. Yeah, up till now it is correct. So what we'll be doing here is that, like, I think we have plugged various things here. So let's we need to be somewhat smoother here. 1 second, like I will be like it became hodgepodge. So like first we deal with integration, p plus 2 का whole square, fine. Then on RHS side we know that 1 minus 2 by p, 1 upon p plus p square at 2p. Okay. Integrating factor p plus 2p का whole square, p plus 2 का whole square, sorry. Integrating factor this was, then it becomes dp. Yeah, I did directly. Okay. So what it comes out to be like L p plus 2 का whole square 1 minus 2 by p it will become 1 plus 2 by p dp, 1 minus 4 by p square, integration will become p plus 4 by p plus c. This will become Lp plus 2 whole square. Now we multiply it, we divide basically. L or p. Yeah, I think we are correct. P plus p, c, p plus 2 का whole square. Yeah. Now we know that L is nothing but Ly. Taking inverse, take inverse Laplace inverse inverse Laplace transform, Laplace inverse transformation both sides. So it will become y Laplace inverse of p by p plus 2 का whole square. Laplace transform of 4 by p plus 2 का whole square. C. Laplace transform p plus 2 का whole square. So if we solve this, it will come out to be this is this was like how, let's see, like this will be this will be t, this will be t e raised to the power e minus 2, this term, fine, this will be and multiplied with c2, this will be 4p square. We can do is that we can take both of them together, like I think so, and yeah, I think so. Laplace inverse of p by whole square. This will become p square. This will become p square. This will become 4. So it will become something like that. Let's make it something this plus 2. So it will be no, it's nothing gonna do make sense. I will be solving this 3. What we can do, we can break the terms. Then what, this is the option that we have. We are crossing the limits of pages. So what we can do, we can break the terms, like we can factorize p square by 4, p plus 2 का whole square, a by p, okay, and then after b by p plus 2 का b p plus c का whole square, b p plus 2 का whole square. I think it should be okay. Because it is 2 degree, then the numerator will be at least of 1 degree, at most of 1 degree. So clubbing it goes like this: a p plus 2 का whole square plus bp square plus cp p plus 2 का whole square, p square 4 p plus 2 का whole square. Okay, so if we compare, p square would be a square plus b square, oh sorry, a plus b then p term would be here, from here we'll be getting 4p, 4 basically here we'll be getting c, and then from here the constant term would be 2c, constant will be 4a. I think we are correct. Yeah, a p square ab 2 to 4 4p 4a 4c 4a, fine. I think we are correct. So comparing, like a comes out to be 1, b comes out to be -1, c comes out to be p, c is nothing but 0. C 4 plus a, 4 plus c should be 0. So it makes c as -4. Yeah. So the entire term would get reduced to y is equals to Laplace inverse of a by s, a by p, Laplace inverse of 4 minus b minus 4 minus p minus 4 by p plus 2 का whole square. Yeah, we are right. This will become 1, and additionally we have c e की power minus 2t. Then taking the minus sign at the beginning. Fine. So what we can do, we can also break it even further. Laplace inverse of p by p plus 2 का whole square. p by p का whole square plus 4 by p plus 2 का whole square. So Laplace is nothing but 4 by 2 p by 2. So how will we doing? 4 by p is nothing but this will become 4 by 4 e raised to the power 2t minus 2t. Okay, and yeah, e raised to the power t. Yeah, and this term would get reduced to what will it become? What we can do? Additionally, we have a term minus e की power c e की power minus 2t t. What will it, I think we are correct now. I think we are doing something error with respect to this term. P by p square, p plus 2 का whole square. What will be its transformation? Yes. Let's see. I think I'm doing something error here. Like how we'll be resolving this. I will come back later. Okay. Going to the first. Yeah, eighth question. Yeah, eighth question is the first part is. Is of the format of Legendre equation, like Legendre equation. Minus 4 x plus 1 minus plus 6y into 6x plus 1. Like while solving ODE, there are few formats that we need to keep in mind. Like ODE with constant coefficients, ODE, uh, ODE with legendary, uh, sort of legendary equation, ODE with variable coefficient and second order. Method of variation of parameters is used in this second order. Then the linear first degree, first order and not first degree. Claret equation is of this kind. So try to identify in which category ODE equation falls. We can accordingly proceed further. So this equation lies in this format. This equation lies in second category, and this equations lies in third category, like variable coefficient, like equation. This one. This lies in first order, not first degree. Like you see, degree is dy by dx, first order, but the power of p is 2, which is not linear. So once we had identified this, it will be easier for us to solve this. So x plus 1 का whole square y double dash. So I'm just assuming, like since we know that this is a legendary equation, so what we do is that x plus 1 put e equals to z, fine, and it can be easily solved. And this type of question we have also solved previously also. So what we can do, yeah, so then it becomes x plus 1 का whole square y double dash is equals to nothing but d by d into d minus 1 y. Basically here d is nothing but d by dz. Similarly, it becomes x plus 1 y dash becomes d y, supporting all this here. So d minus 1 y d minus 1 minus 4 dy plus 6y is equals to, we can also substitute it in the terms of z only, 6 e raised to the power 2z, 6 e raised to the power 2z, x square is e raised to the power 2z plus sine log z, I guess. Sine x plus 1 is nothing but z, sine z it will be nothing. So this type of equation we have solved. We will be solving for homogeneous, and then we will be solving for particular, and we can solve that way. So solving complementary function, this will get reduced to d square minus dd minus d minus 4d plus 6 equals to 0. Then it's become d d square minus 6d minus 3d minus 2d minus 3d minus 2d is equal to plus 6 equals to 0. Then it becomes d equals to 3d and d minus 3 minus 2 d minus 3 is equals to 0. That means d is 3 or d is equals to 2. The y complementary is nothing but c1 e की power 3z plus c2 e की power 2z. This is complementary. Then now we'll be solving the particular solutions. So y particular is 6 e की power 2z, 6 e की power 2z divided by this term d square minus 5d d square minus 5d plus 6. Then after sine term sin z d square minus 5d plus 6. Now put d is equals to 2 in order to solve this, but on putting this 2 it will get 0. So what we do in order to solve such kind of problem is that put 6z e की power 2z, differentiate denominator 2z 2d minus 5 and now put d is equals to 2. Here we will be putting d square is equals to minus a square is basically 1. So it will become sin z d square minus 1 plus 6 5 minus 5d. Okay, now we'll be putting 6z e की power 2z 4 minus 1 then this term get reduced to this format, and now we'll be solving this. What we can do is that we can rationalize 1 plus d square sin z. We can also do is that we can do if we put minus 1 it will become 0. We don't want to do that. So what we can do here, like we can do we can take it up at the upper end and we can do expansion 1 minus d minus, I think we are correct, sin z yp is equals to minus 6z e की power 2z plus 1 by 5 1 plus 6d and 6d plus d square, something like that. Will keep on going. I think we are correct now. Yeah, I think so. Yeah, so then after what we can do is that fine, we can proceed this to any number of times, but we'll be doing only 2 terms and we'll be leaving that. 6z is e की power 2z plus 1 by 5 sin x, sin का differentiation cos z, sorry it is in z. So this become our particular solution. What we can do now, that replace y z with respect to x. So put log x ex plus 1 is e power z. So we can put it here, y is equal to y plus c plus y plus p, and y we know yc is nothing but this will become in by substituting in x plus 1 का whole cube plus c2 x plus 1 का whole square, then minus 6 ln x plus 1 का whole square plus 1 by 5 sin ln sine ln x plus 1 plus cos ln x plus 1. This is our final solution. I hope we have done correctly. Now this is the answer. So moving to the second question. 9p square 9 part 2 9p square minus 2 minus y का whole square is equals to 4 into 3 minus 1. So it is of category 4, like it is first order but not first degree. So in order to solve this, we can factorize it. Like there are 4 ways we can 3 to 4 ways are there. We can solve through this. We can solve it. One of the method is claret. One of the method is p f of xy, something like that. We can make it factor. We can make it claret. CLAIRAUTH. Clarets. Factorization. Rather. Factorization.